All right, so all of our lathe work is done. I'm real happy with the part. It looks good, it feels good. We hit all our dimensions just like the print wanted us to. So lathe work is finished. So the next phase of the project that we need to get on now is going to be this internal keyway. So this is a 1/4 inch wide keyway, and then you also have this wider keyway that's milled in this outer face there that we got to do. But I think what we'll do is focus on this internal key first. I've got to find my tooling. I packed up all of my broach tools, put them in a bin. I brought it down here. So I've got to dig through that bin and just find the bushing and the cutter and the shims that I need to do that. And maybe our green at Arbor Press here will help us get this done. If it gives me too many problems, we'll have to go down and to the home shop. I've still got my electric press wired up and set up there, but we'll see how it goes. So internal keyway, and then the last phase will be this notch, this slot that we got to mill in there, right there. Okay, I did find my broaching tools. We've got an 1 1/4 inch broach bushing here, and I think I have over the years, there must have been a job that we had to either turn or polish that down because it's got about 5 thou clearance in there, but that's going to be just fine. We've got a 1/4 inch push broach here. It still feels good, and we got a couple of shims there as well. All right, so I am going to try the green at Arbor Press here and see. The only problem with this is when we're using this size broach right here, which is the type C, is the total height. So what I have to do is I have to kind of start this. I have to get it started down in there so that it will fit inside here. You can see right there it just about doesn't fit. And what I do for that is I usually take a copper or brass hammer and I tap it to get it started. So that's what we're going to do there, okay? So we're also going to use our anchor lube today on this broach. So we've got a little acid brush here, and I'm going to go ahead and just coat this down with some anchor lube. Get it on the sides too to help get it to slide through there. On the back. And we'll see how that's going to do, all right? Broach plug in there, and then what we're going to do is go over to our big fireball vise and use that to help tap this down in there. We're just using this. It's got this V notch in the center there. And we can put this down in there, tap it in. That might fit. Let me go ahead and test it. Nope, it's got to go down a little bit more. See what I'm talking about. You got to get it through there. That's why I like using the electric press whenever I have to do some broaching. That's going to work right there. All right, you can see our broach is going to fit in there now. It's going to take some tonnage to get it going. You can see just how much force it takes to push even a 1/4 inch wide push broach there. But we got it. Taking a look at our chips. Looks pretty good. There's our first pass, so we're going to go ahead and put a shim in there and reset. Now we got our shim. Got a chip in that rag right there, and I just wiped my finger and cut my finger open. It's not bad. Little surface wound. It'll be all right. See if it fits. And it does. I think that's all we're going to need for the broach there. I've got this measured using my scale, and it's 1/8 deep right there where it's at. And one of the things that they had mentioned was that the key didn't need to be the full depth on this side right there. It's actually, they're using some kind of rectangular key, so it doesn't have to have the full depth there. So that one's measuring at 1/8, and the one that I just cut here is the same thing. It's measuring at 1/8. So I think we're good. Just got to do some deburring in there on that, and then get this stuff cleaned up here. Well guys, I messed up whenever I was moving on to the mill for this segment of the job. I forgot to turn my receiver on the mic, so I went through all the setup and indicating process here and didn't capture any of the audio. So I'm going to watch it with you and see if I can just kind of talk my way through it and explain what it is that I was doing to set this part up. We have the internal keyway, which we've already broached, and now we have that one keyway that's got to be milled on that outer face. And so what I chose to set this up to do this simple job, I'm using one of my Fireball tool V blocks. This is typically used on the welding table, but it's a good tool to use for different setups, especially something like this here. So what I was going to do is set the V block in the vise. I'm also using one of my Fireball magnetic shim blocks there that I'm going to set the part on, and the only reason why I'm setting it on that shim block is to raise it up just enough so that I can easily indicate the OD with my coaxial indicator later. So we're going to use a piece of 1/4 inch key stock. We're going to stick it in the key, and what I want to do is make sure that part is rotated exactly in line with the x-axis of the milling machine. So I put that piece of 1/4 inch key stock in there. I'm using a small C clamp to clamp it to the keyway and make sure that it's tight. Now I'm going to take another one of my Fireball tool magnetic shim blocks. This is just to provide me more surface area to indicate on. So we're going to stick that shim block on that piece of key stock. I got another small C clamp there. This is why it's handy to have all different kinds of C clamps in your toolbox. They're always handy. But I'm going to clamp that shim block to that piece of key stock, pull it up tight, and that should provide a pretty nice flat surface that I can run the indicator on and try to get that part rotated in the orientation in which we're going to be indicating is going to be in the y-axis. So I've got a Noga arm set up with a Starrett test indicator. We're just going to mount it right there in that side hole in the spindle of the or the mill head, I'm sorry. And I'm going to use this test indicator. We'll get it set up on that shim block, and we're going to move the part in the y-axis back and forth and just get this part indicated so that what should be the very center. The keyway should be oriented whenever you're looking at it at exactly 3 o'clock position, so that when we come in there with our end mill and we mill that key over that face, that it should be near perfectly aligned with the keyway that we broached down in the center bore. So we've got it set up, and I just eyeballed it at this point, seeing how far out it is. I think I was somewhere around 4 or 5 thousandths out. And this is a pretty simple one to get indicated. So we just crack it loose enough where it'll rotate, and just I'm just moving it around by hand at this point, trying to split the difference on the indicator and see if we can get it lined up. And I get it pretty close here, but we will go back in there and have to move it another time or two, I believe. But this was a pretty simple solution that I came up with that I thought would work really easy to get this keyway aligned. Here's a little close-up video that I got. I always try to get in there and show you guys a more detailed video with my other camera there, so you can see it a little bit better. And I believe this is the part where I got it really close. So it looks like we're within about 1 thousandths at this point. Just resetting, getting rid of sort of the backlash in the indicator there, and we're going to check it again. Let's see how far out we are here. So about 1 thousandths across the width of that shim block. But I believe we can get this a little bit closer. So we're going to go ahead and loosen it up one more time and see if we can split that difference. And I just simply, you can see I was just using my finger there and just tapping it, and we moved it about 1/2 thou. And I believe at this point we are pretty darn close to being true on that key. So I'm going to call it good right there, and at this point we're going to tighten up the vise, and we're going to consider the part
it's probably about 1/2 thou
trammed in, whatever you want to consider this part. We're indicated, and that keyway should be aligned in both the X and the Y axis there. And so we're just going to go ahead and we'll break this setup down, and then we're going to move on to our installing our end mill. Not quite through indicating it yet. After we get this broke down, we're going to set up and indicate the very center of our workpiece. So for this, I'm going to pull out my Blake coaxial indicator. Love using this indicator anytime I can. It's a pleasure to use. So I wanted to go ahead and talk about this indicator a little bit more for this job, just a discussion, because sometimes when I use this in a video, you'll have guys mention that, you can rotate that, you can turn your spindle on and just let it rotate and then move the handles to center it up. And I wanted to talk about that here and just discuss why you really never see me do that. And that's why I hate that I lost this audio, because I don't remember everything that I said, but I'm going to try to recap that here. Whenever you turn it on, see, I turned the spindle on there, and that's rotating, I believe, like 50 or 60 RPM. That's the lowest the mill will go. My mind and my eyes, I can't react fast enough to this indicator and make sure that I'm moving the mill handles, the XY handles, in the right direction. And I end up, a lot of times when I'm doing it, sometimes you'll get lucky and you'll get really close. You'll be moved the right direction. But oftentimes you move it the wrong way. And then you just ended up chasing yourself, trying to get that needle to stop moving. And so for me personally, just the way that I like to do it, I like to rotate it by hand. And think of it like indicating in a 4-jaw chuck. I'm usually looking 180 degrees apart. All right, and that's exactly what I'm doing right here. I'm lining it up in the X travel right here, and I'm going from one side to the other, and I'm trying to split the difference there. Once I get it close in one direction, then I go to the other direction. Like right here, we're looking at Y. Now we're back on X. But for me, just rotating it by hand and visually watching it is the best way for me to use a coaxial indicator. And I can actually get it done faster that way versus turning the mill head on and watching it rotate. So this depends on your personal preference, what you like. You can do it either way. If you like turning the machine on and watching it rotate and line it up, then go for that. It works the same. I just like doing it by hand whenever I get a chance to use it, because it works better for me, and I seem to get it indicated faster than whenever I'm turning the mill head on. I just realized that all that indicating that we just did there, I did not capture any audio, so I'll have to do some voiceover to kind of explain what all we did there for setting it up. So I hate that, because when I go to edit the video, that just means there's more work, even more time that I got to put into it, and watch the video and then collect my thoughts, and then watch it again and try to talk over what it is that we did in a previous job. Not my favorite way to do video editing, but that's what I'm gonna have to do because we already got all this stuff indicated. So anyway, let's move on to our end mill. In the previous video, we did the pump shaft and we milled a 3/8 keyway using our new Titan USA cobalt end mill here. We're gonna use that same exact end mill for this job here since this is a 3/8 key slot. And I was talking about how I got a few of these Titan end mills here because all of my high-speed steel and cobalt end mills have been used and abused over the years, and I haven't had any new ones in a long time. And I was ready to get a fresh brand and put a few in the drawer. So I got these Titan to try them out and see how they do. And that previous job, it did excellent. We used this 3/8 end mill here. This is a perfect cutter for general purpose work over here on the manual mill. And this is the cutter that I've always had the best luck with whenever we're milling keyways. All right, I just want to make sure we're using the same end. It looks like this end here has got the oil on it, so we're going to use that end. Going into, let's see if I can get it in there. Going into a 3/8 collet. Okay, we're already in the center, so we're good to go there. I just want to kind of visually inspect it here and see if it looks like it's in the center of that keyway, and it does. Perfect, it should be in the middle of that. So from here we can just touch off. And I think I'm going to try full depth, which is 5/16. So we'll touch this face, bring the knee up 5/16, and mill our key. I am going to use our trim mist for some coolant today, going through this little Noga mini cool here. So let's get it positioned where it needs to be before we get started. All right, that looks pretty good. All right, we just brought the knee up 5/16. A little bit too deep. Let's see if we can kick our feet up a little. All right, a little bit too much. We're going to drop it down 100,000. Gonna feed it by hand. All right, we've got a .375 gauge block stack up, and this is fitting our slot nicely. We get it down in there. There's our 375 gauge block stack up. I started with 374 and it was tight going in there. So I ran back through there with a spring pass. It was still a little tight. So what I did is I made it a 1/2 thou adjustment, and I'm able to get this 375 in there now. And I'm going to show you what I do. And whenever I'm offsetting a key like that, you know, like a thousandths or a 1/2 thou per side, I like to put the edge mag back indicator here on the side of the mill and preload it, set it to 0. And I feel that this is more accurate doing this than relying on this digital readout up here, because I have seen where this right here throws me off and I'll end up milling something too big. So when it gets down to the final 1 thou, maybe even thousandths and a half, I'm just not really trusting these scales the way that I should be able to rely on them to make an accurate offset. So my fallback is always this, and it works excellent doing that right there. So our part is finished with a little bit of deburring I got to do there, but our part is ready to go. And you saw earlier, I was trying to do that full depth with the end mill, and I thought I would just give it a shot. I didn't know if it would work or not, but that is typically the results I get when I try to take close to a full depth compared to the diameter of the key, or the diameter of the end mill there. This thing fits that collet so closely there. So stepping it down halfway was the trick on that one. That worked better. And it cleaned up, the sidewalls of the key is cleaned up nicely too, so it doesn't have any chatter in there. Vice handle, looking to where I put the vice handle. Here it is up here. All right, that looks good. All right, guys, well, that is going to wrap up all of the machining needed for our steady bearing bushing. And I'm real happy with the results. I think it looks good. We hit all of our specs right where we wanted to be. And it was a pleasure being able to machine this material again. It's been a while since I've machined some 12014, and it is a really nice material to machine when you have the luxury of being able to use that. So this guy is ready. I just need to give them a call so they can come and pick it up. I know that they were anxiously ready to get this back in their hands, and it is ready to go. But I did talk to the customer, and he did explain to me how this part is used out there in the field. And that's something that it's pretty rare that we ever get to find out how exactly parts are going to be used out there in the world. And we just don't always have the luxury of getting any kind of photos or videos of the end process of how something's going to get put to work. But this right here, it goes to an auxiliary power source at a paper mill that will run a water pump in the event that they lose power from the power grid. So power goes out at the paper mill. They have all of these machines that need to keep operating. So they have this big water pump hooked to some kind of generator or some big engine. I don't know if that's a diesel or a gas engine, no idea. But you have an engine that is coupled to an Amarillo gear reducer, which is then coupled to the water pump. This goes in that line somewhere. I believe probably it's either going to be between the engine and the gearbox, or the gearbox and the pump, somewhere in there. I'm not really sure because I don't know. I didn't even ask that specific there, but it goes in that line. And of course, you're going to have a new bearing that goes on there, and there's some kind of housing that this also goes in. And this is going to support a shaft going through there where everything is lined up and coupled together. Okay, so that is how this is used. And unfortunately, we do not have any photos or videos of showing that, but I did want to try to explain how our part that we machined today is put to work out there. And again, it's for a paper mill. I have no idea what paper mill it's for, but that's something that I've talked about in the past too, is the important role that these big paper mills, that a lot of people, they drive by them and they don't give them any thought other than it's an ugly industrial complex over there. But when you go by a paper mill, for example, Georgia Pacific, they're all over the Southeast, those type of paper mills help provide the products that we're all used to go into the store and buying. Commodity items such as your toilet paper, your paper towels that you use, boxes. You know, anytime you buy something, it comes in some kind of cardboard box. You know, you go pick out your favorite cereal, it's usually in a cardboard box, and any other item on the shelf. And that's where these paper mills come into play. They take the wood pulp and they convert it into paper, whether it be for paper towels or it be for cardboard boxes, but they provide those services that we all rely on every single day. So next time you go to the store and you're picking out your toilet paper or your paper towels, or you pick up a box, think about the industry that's required in order to make that one product that we're all used to just being able to go to the store at any time and just pick up off the shelf. All right, so this goes to a system that is put into place so that if they lose power, they can continue operating even when the power grid is actually down. So it always feels good having something to do with that, you know, helping out and being able to play a very small role in helping to keep the industry moving and helping to keep the world rotating, you know. So there's one of our small little contributions to that. And I just wanted to throw that out there. So next time you go by a big old ugly industrial plant, just think about what role that they may be providing for your everyday life and needs. All right, guys, I hope you enjoyed the video, and I hope you come back for another project. We do have another job over here lined up on the table that we need to get started on for our pump customer. We've got some pipe flanges that we need to machine. So we have that coming up, and I've been running production. I'm getting ready to go over to the VM now and get it fired up. I got to do some more engraving on our drill indexes and keep those rolling. But we've got plenty of machining projects still lined up that I got to get to. So I hope you come back for some more, all right? We'll see you then.